Let us solve the problem. Let f be a function analytic in modulus of z less than 1 and such that integration modulus z equals to 1 fz by n plus 1 into z minus 1 dz equals to 0 for all n belongs to natural number. Then 1 fz equivalent to 0 in modulus of z less than 2, 2 fz equals to constant not equals to 0, 3 fz equals to z, 4 fz equals to z square. Which one of the following statement are true? Let us solve. To solve this problem, we need a formula which is known Quasi-Integral formula, and we need another theorem, identity or uniqueness theorem. So first we defined Quasi-Integral formula and identity or uniqueness theorem. Let fz be an analytic function within and on a closed cone to C, and let a be any point within C. Then f of a that equals to 1 upon 2 pi I into integration over C fz by z minus a dz. This is the Quasi-Integral theorem formula, not theorem, Quasi-Integral formula or uniqueness theorem. What is the identity theorem or uniqueness theorem? Suppose f is analytic in a domain D if A is the set of zeros of f in D has a limit point in D, then fz equivalent to 0 in D. Our problem is integration modulus of z equals to 1 f of z by n plus 1 z minus 1 that equals to 0. That implies modulus of z equals to 1 fz by z minus 1 upon n plus 1 that dz that equals to 0. Since fz is analytic on modulus of z equals to 1, so by using Quasi-Integral formula, let fz be analytic within and on a closed cone to C, and let a be any point within C, then f a equals to this. fz is analytic in modulus of z equals to 1, okay, and this 1 upon n plus 1 with the a, here a equals to 1 upon n plus 1, therefore by Quasi-Integral formula f of 1 upon n plus 1 2 pi I equals to integration of modulus of z equals to 1 this equals to 0. That implies f of 1 upon n plus 1 that equals to 0. Now f with the 0 at the point 1 upon n plus 1 where n belongs to natural number. So here S be the set 1 upon n plus 1 such that n belongs to natural number. Be the set of zeros. Limit point of the set S be 0. 0 belongs to modulus of z less than 2. Then by identity theorem, since fz, what is the identity theorem? Suppose f is analytic in a domain D if A is the set of zeros of f in D has a limit point in D, then fz equivalent to 0 in D. Here the point is that 1 upon n plus 1 this is the set and 0 be the limit point of this set, okay, and fz is analytic in modulus of z less than 2 and 0 belongs to that set. Therefore by identity theorem f of z equivalent to 0 for modulus of z less than 2. Now solve this problem. What can be said if above problem replaced by this? Integration over modulus of z equals to 1 fz by n plus 1 into z minus 1 whole square dz equals to 0 for all n belongs to n with same condition, that is fz is analytic function in modulus of z less than 1. This condition, to solve this by previous way. If you any question, any doubt, please message me. To solve interesting problem like this, please subscribe, share and like my channel. Thank you.